We're starting 5.4, common and natural logarithmic functions. Logarithms are the inverses of exponential functions. If f of x is equal to 10 to the x, then f inverse of x is equal to log base 10 of x. If f of x is equal to 5 to the x, then the inverse of f is log base 5 of x. Right now, we will only be dealing with logarithms that are of base 10. On your calculators, there is a log button. This right here. The calculator can only do base 10. What that means by base 10, we're counting by tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and just keep going through. That's the way we count. Base 5 is different. Base 5 can only use the numbers up to 5. So it's 0, 1, 2, 3, 4. Now it starts over again. What's my first number after that? No. Okay. 0, 1, 2, 3, 4, 10, 11, 12, 13, 14, 20, 21, 22, 23, 24. You only have the numbers, the first 5 numbers. That's it. 0, 1, 2, 3, 4. Just like log base 10, you only have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it starts 10. Goes through. So I have log of 1,000, log of 1, log square root of 10, log of negative 3, log of 6, log of 327. Just write them down. When you see just log of 1,000, that stands for log base 10 of 1,000. If you do not see a base on a logarithm, it automatically stands for base 10. So this is another way you might see it. Log base 10 of 1,000. Now you have to remember these are inverses. If I have 10 to the x, or if I have log base 10 of x, that actually means 10 to the x, right? This right here, I need to find out what the log of 1,000 is. To write this exponentially, that's like having that equal to x. This is base 10. 10 to the x is 1,000. 10 to the what power is 1,000. How did you get 3? All right. You have to know how to do these without a calculator. I know you can sit here and go log of 1,000, and then it tells you 3. What this means is 10, because that's a 10 here, 10 to the what power is 1,000. X has to be 3. Whoops. Because if there's no number attached to the log, there's no base, it's automatically a 10. So this means 10 to the x is 1. Bless you. What exponent will give me a 1? 0. Now I can hit log of 1, and it will tell me 0. 10 to the 0 power gets me 1. Right. Correct. Now, this would mean 10 to the what is the square root of 10. This means to the would you say the half? Now I can take in the calculator, put square root 10, I get 0.5. Log of negative 3. This means 10 to the what is negative 3. What does the base mean? Okay, if I had 2 to the 5th, what does that mean? 2 times 2 times 2 times 2. Okay, what times 10, or 10 times itself, how many times is it going to get me a negative 3? Okay, it has to be a fraction to get a 3. How about a negative? That was just a little side note. Try your calculator. What happens? If I hit log of negative 3, I get non-real answer. There's no solution. You can't take the log of a negative number. Right, that's sort of like what you're doing. You can't have a positive base get me a negative number. This one over here means 10 to the what is 6. Will a whole number get me 6? No, because 10 to the first gets me 10. So I'm going to use log of 6 gets me approximately 0.778. Yeah, that's what we're trying to do. And this one I'm just going to take log of 327. It is about 2.515. Questions on basic logs right now. So logs are the opposites of exponentials. I have log of x equals 2. I can't solve this in the calculator. I can't put log x equals 2. Now, I need to rewrite it. What's my base really right here? 10. What's another way I can rewrite this? Okay, change the log into exponential form. 10 to the second power equals x. The way to think of these problems, changing from a log to exponential, it is always the base to the answer equals the middle part. Changing from log to exponential, it is always base, exponent equals the answer. It's rearranged. 10 squared is what? 100. And that's what 2 is. The log of 100 is 2. How can I solve this one changing it to logarithmic form? Log, and that's base 10, of 35 equals x. Log of 35 is about 1.544. You understand what I did? Before, we couldn't do this problem. On the last section, when you had to find out how much time with that decay problem and stuff, without knowing logarithms, you couldn't find out to the x power. But if I can take it and change exponential into logarithmic form, you could have found out how many years it was without having to go in the graph and trying to find it from the table. Now, if I take second log, that takes 10 to the answer. I get 35. So 10 to the whatever this was will give me 35. Now, of course, if I do 10 to the 1.544, do I get 35? No. Why don't I? We rounded. That's why. The natural logarithm. Why did I? No, I was just showing you that it's not 35 because we rounded. To change a log to exponential, that's a 10. So 10 squared equals x. It's always the base. Your exponent equals whatever's on the inside there. The natural logarithm. The natural logarithm, which is ln. ln is the inverse of the e function. Now, ln of 14. Remember how you got to e? You had to do second ln? Just take ln of 14. It's about 2.639. Now, if I have e is, what did we say e was? 2.718, blah, 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 blah. Now, if I take the ln of e, whoops, ln of e. Now, I got to put e to the first. Second ln. I get what? You should get 1. Because an ln cancels out an e. An e cancels out an ln because they're inverses of one another. Remember, 3/4. What's the inverse of 3/4? 4/3. ln is the inverse of e. They get rid of one another. You're just left with 1. The same thing with this stuff. ln of 1/5. ln 1/5, enter. Negative 1.609. What's that? You can get a negative number as an answer. Right. Because what this means is if I had e to this number, it will give me 1/5, 0.2. If I take e of, get that whole decimal back up there. If I take e of that decimal, it'll give me 14. E to that will give me 14. Just like on the last one, 10 squared will get me what x is. 10 to the 35th is what x was there. Sorry, not 10 to the 35th. Do you understand logs and ln's? All right. Open your books to page 361.